Dear friends, here we have a Japan Math Olympiad preliminary problem that has appeared in the year 2016. The question is, calculate the value of square root of 11 power 4 plus 100 power 4 plus 111 power 4 divided by 2 and answer in the form of an integer. Now to solve this problem, there are two obvious facts that help us get started. That is, the answer is an integer should tell us that the expression inside the square root is a perfect square. That is, we can write the square root of 11 power 4 plus 100 power 4 plus 111 power 4 divided by 2 in this form, that is, square root of 11 power 4 plus 100 power 4 plus 11 plus 100 the whole power 4 divided by 2. So now this is of the form square root of a power 4 plus b power 4 plus a plus b the whole to the power 4 divided by 2, where a will be taken as 11 and b is taken as 100. Perhaps we should generalize and see if this is a perfect square. That is, the term inside the square root is a perfect square or not. We shall now consider this a to the power 4 plus b power 4 plus a plus b the whole power 4. Now this can be written as a to the power 4 plus b power 4 plus this a plus b can be written as a plus b the whole square, and that is equal to a to the power 4 plus b power 4 plus, now this a plus b the whole squared can be expanded as a squared plus b squared plus 2ab the whole square. Now here we will be using a formula so that we can expand this term. First of all, we will write this a to the power 4 plus b to the power 4, and the formula that we will be using here is this, that is x plus y plus z the whole squared is equals x squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx, where x is a, y is b and z is 2ab. So using this formula we can expand now. So what we obtain is a power 4 plus b to the power 4 plus 4a squared b squared plus 2a squared b squared plus 4ab cube plus 4a cube b. Now combining the terms a power 4 plus a power 4, we get 2a to the power 4. And the term b power 4 plus b power 4, we get 2b to the power 4. And now these two can be combined and it can be written as 6a squared b squared. And then plus this we have to write as it is. So 4ab cube plus 4a cube b. So we started with this term and we have obtained this. Now if we divide this term by 2, so that is a to the power 4 plus b to the power 4 plus a plus b the whole to the power 4 divided by 2 will be equal to. Now we have to divide this whole expression by 2 and we obtain a to the power 4 plus b to the power 4. And when 6 is divided by 2, we get 3a squared b squared plus, now 4 divided by 2 becomes 2ab cube plus, now here again 2a cube b. So this is what we get. We shall now try to match this to a perfect square expression. The a power 4 and b power 4 terms suggest that there should be a squared and b squared terms in the square. So this can be matched with terms like a squared plus b squared plus x the whole square. So we can match this expression to this. So that will be equal to, we will write this expression, a power 4 plus b power 4 plus 3a squared b squared plus 2ab cube plus 2a cube b for some x. Now let's expand this expression and see what x could be. Now to expand the left hand side we have to use this. That is, at the place of x we have a squared, at the place of y we have b squared, and at the place of z we have x. So when we expand it in this form, what we get is a to the power 4 plus b to the power 4 plus x squared plus 2a squared x plus 2a squared b squared, okay, and then plus 2a squared with x plus 2b squared with x. So this is the expansion of the expression on the left hand side, and on the right we have this to be equal to, so on the right we have a to the power 4 plus b to the power 4 plus 3a squared b squared plus 2ab cube plus 2a cube b. So now after this we can compare here and we can cancel out these two terms and b to the power 4, and we can cancel one of the 2a squared b, and here the remaining part will be a squared b squared. So we are cancelling 2a squared b squared, and we observe that a squared b squared is left out in this, and the remaining all is the same. Now what we can do is we can take x common from these three terms on the left. So what we get is x we are taking common, and so within the bracket we will be having a x here, and then here we will have plus 2a square plus 2b square, and on the right we will be having this to be equal to, we can take AB common from these three terms, and so AB multiplied with, in this term AB is left out, and in this term plus 2a squared is left out, plus in this term 2b squared is left out. Now comparing the left and the right, we observe that the value of x is equals AB. So we obtain the value of x to be equal to AB. So it's clear that x equal to AB fulfills this expression, that is, this to be equal to this square. So for this expression to be equal to this square term, we should have x to be equal to AB. So that we can, when we take the square root of this, it will be equal to the square root of this, and easily we can find it. So this is what we obtain. Now taking the square roots on both the sides, if you see here, the square root of this is what we require. So that will be equal to the square root of this term. But that will be equal to a squared plus b squared plus x is ab. So this is what we obtain. Now we know that a we have taken to be 11 and b is 100. And so therefore we will be having square root of 11 squared plus 100 power 4. I'm sorry, not squared, it's power 4 plus 111 power 4 divided by 2 will be equal to simply this term, where a is 11 squared plus b is 100. So 100 squared plus 11 multiplied with 100, and so that will be equal to 121 plus 10,000 and then plus 1100, so 1100, and so the answer will be equal to 11221. So this is the required integer solution. So therefore the answer for this is 11, that is the value of this term is 11221, so which is an integer. Hope you had a great session. Happy learning. Thank you.